Hello everyone, my name is Bushra Derbi. I am a PhD student at the University of Liverpool in England. Today I'm going to talk to you about the embodied carbon analysis of a nearly zero energy building in ZIP house in the UK. The construction industry is changing rapidly where sustainability has become the key word, driving all innovation. Every new material is graded for its environmental impact, and the most commonly used technique is for this, the life cycle assessment. This paper attempts to look at the LCA for the specific magnesium oxide structure insulated panel used in a home in North England. Globally, buildings and construction accounts for 36% of global final energy use and 39% of energy-related carbon dioxide. Under the Climate Change Act of 2008, UK has been committed to reduce the greenhouse gas emission by 80% in 2050. Now, the roadmap to reduce the energy use is mainly focused on the operational carbon part of it and not the embodied carbon of it. And then there are these medication that they have been put in place. Measures can be grouped into two main categories, which are the building envelopes and the internal loads. Building envelopes, of course, consist of walls, floors, ceilings, and roofs. And then the internal loads is the technology used to operate the building. So to study the embodied CO2 emission of the MGO subsystem, a single family home was selected in Heswall, north of England. You can see the map on the right hand side. The total built-up area is 92 meters square. The house consists of one bedroom, one bathroom, one living room, kitchen, and an office and utility room. And in this slide, you can see their floor plans and sections, north and south facade of the building. To calculate the total carbon emission from the SIP homes, I've used one-click LCA. It covers all life stages, cycle stages from cradle to grave, with separate reporting to the extraction of raw material, manufacturing, transportation, on-site constructions, operation and disposal and reuse at the end of the life. However, I have eliminated the operational part of it because I only wanted to focus on the embodied carbon. Now, to go back to my questions, I wanted to know if these new technology materials used, called the MGO SIP panels, are they fit for the future? Are they the answer for the roadmap of 2050? And it was found that the total embodied CO2 emission of the magnesium oxide SIP home is about 18 kilogram of CO2 emission per meter square per year. When compared to the NZIP target of the UK, so the MGO SIP house has a relatively small amount of carbon emission. However, the number could have been nearly zero if the transportation of the MGO was sourced locally. The mode of transportation plays a major role in calculating the embodied carbon because it relates to the consumptions of fossil fuel. Especially when the MGO SIPs panels are transported all the way from China warehouse and assembled in England. So if we eliminate that part of transportation, yes, the manufacturing locally and sourcing these SIPs locally could play a major role in changing the way we look at buildings, and then they could be the answer and they could be fit for the future. But currently they're not, and the main reason goes to the transportation from China. I hope you have enjoyed my presentation, and thank you very much.